Yes, so as Miles so delightfully introduced, I'm Colin, on a theme of Collins, and I'm doing Pedro's talk. I have changed it. You probably see the bits I've changed it to, if you remember Pedro. So we're going to talk about validating Shiny apps in regulated environments. Okay. I'm sure the title is, and sort of once you read that, you think, oh, this is going to be exciting. What could be better than a validated Shiny app? Doesn't that sound fun? But I'm going to make it, at least try as hard as possible to make it fun. So what should a good Shiny app be, right? So it should be reproducible. I think that's sort of obvious. You know, it should sort of work. It should have documentation if we're really pushing the boat out. It should be traceable. So quite often we go to companies, clients, and there's a Shiny app that thou shalt not touch because we're not quite sure who made it, how it's running. Just don't touch it. Everybody take a step back. So it's sort of traceable in terms of, you know, just where it comes from, who's looking after it. It's all a bit unclear. And it should be expected to work, right? I think that's not controversial. And a validation is just about making sure this stuff is true, right? That's all I'm going to say. Is validation is going to be making stuff that is true. So I'm going to agree, I think we'd all agree that all that stuff is good. We'd all probably want it in our own work. We'd probably all confess that we might not always get there because other things are pushing, you know, other priorities. But validation is making sure that this is achieved, and also that it's documented in such a way that you can demonstrate it. Okay, so you're probably sitting there, it's like, I don't care about validation, right? I'm sure you're not, but just in the off chance you don't care about validation. So what I've done is got a nice line, because you can't beat a line, and on one side we've got validation, right? So in validation here, I'm sort of thinking about GXP pharmaceutical companies, heavily regulated companies. That's what I'm thinking about validation. So what's in the opposite end of validation? Not that, because that's going backwards. Toy project. So that's the sort of stuff that you mess about at home. You know, you're a bit bored, you're sitting in front of the telly, you get your laptop up, you just sort of play about. That's where I'd say, you know, the opposite end. And then you might have homework. Not many students I worked with have thought about validated homework. So we've got that sort of stuff. Maybe a demo. It's getting a bit more along there. So you're building something just to sort of try. Maybe show to someone in the desk next to you, maybe thinking about, you know, demoing a boss. Then you've got sort of internal projects. So what's an internal project in my mind? Something that you use, but if it suddenly went belly up over the weekend, you don't have to rush to the office to fix it. And if it was a little bit wrong, it's not going to be like, oh, everyone must fix it. It must be fixed right now. Drop everything you're doing, that sort of thing. So it's important, but not absolutely critical, okay? And then we've got sort of mission critical stuff, and this is sort of really important where actually if there's something wrong, it has to get fixed, and really we don't want anything wrong with it. And if it goes down, it's going to be a priority to fix it. And then sort of try to structure it of going from, I don't want to say bad software practice, but I suppose more lax would be at one end, and then as you're going through this, you're going to sort of ramp up your processes, ramp up your thoughts, making sure things are a bit more clear. You know, if something's mission critical and you don't have any documentation, can't be that mission critical. Actually, that's just wrong. Of course it can be mission critical with no documentation. It just shouldn't be a better way of thinking it. And I'm going to argue that everybody in this room is probably over this end, right? You know, you've probably got building Shiny apps that either you use internally, so it might just be for yourself, but you're using it in anger to get some answer, or you might even be in the unfortunate position where you've written an app and people depend on it, and no one ever says, what a wonderful app, they'll never complain when something goes wrong, right? I'm thinking everybody's here. So I don't care about validation. Yes, you do. You just didn't know it. And you just didn't know it yet. Okay. So since I've bought a license for Slido, we're going to flog this particular horse. And what are the good software design practices in Shiny, right? So this is where you get a chance to scan QR code here, type in some stuff. It's going to go live, so nothing rude, naughty, or bad. It's mainly to people from Jumping Rivers. So give it a couple of minutes. And if anyone says, I'm just padding out this presentation, you're wrong. That's not true. Right, so I'll give you 1 minute and start. Hopefully it should just, yes, 4 participants are typing. Is Gollum by anyone French? Okay, so we've got, let's give it another minute. Good. Okay, so while people are still typing, what proportion of people actually have tests in their Shiny app? Just so hands up if you've got some tests in your Shiny app. I don't just mean 2 plus 2 is the default test. So hands up if you've got tests in your Shiny app. I'd say about a third of the room. And we've got tests, unit tests, testing somewhere else, legal bits, so not to get too technical. Okay. So I think, yeah, testing's clearly good. Got some design, I've got that part. Some accessibility, yep. Security is probably a good thing. Performance, does it work? Logging, yep. A good Shiny app has spaghetti code, okay. We can probably agree to disagree on that one, but yeah, okay, fine. Yep. So if you still don't care for the rest of this talk, just substitute good app design for validation, right? So if you think I actually still don't care about validation, everything else I'm going to talk about, just substitute the word good app design, right? That's what we're talking about in validation. Okay, so last year we started working on something called Litmusverse, right? I've only got 2 slides in this, so I'm not going to cover too much. But essentially, it's validation for R packages, okay? So you've got an R package. IT says to you, can I trust this R package? Does it work, right? And this is a way of validating or assessing R packages, okay? So the idea being that it's the scoring, so we can look at things of how many people use a package, how long it's been used, does it have tests, does it have documentation, all that sort of stuff. We combine it to combine all those components into a single score, and then we can get an idea of how trustworthy a package is, right? It's a bit more nuanced than that, but that's essentially it. And it's built for, there's an interactive dashboard, so there's a link in the next page where you can sort of view about 1,000 packages, and then you can see, do I trust this package, do I not trust this package? The idea being that the word trust is vague. The word trust for doing your homework is completely different from the word trust working in insurance, right? So trust is sort of fluid. But it's an idea of how do you do that assessment over hundreds, if not thousands of packages, okay? And this is sort of what it looks like. I think that takes us to the dashboard. This part here is the screenshot. So essentially, you've got 1,000 packages. Each are given a score between 0 and 1. The idea being that you'd look at the ones that are perhaps risky and then go away and find out about them and then make a conscious decision about should you be using those packages, right? So that's what Litmus is doing. Litmus is taking a package, any old R package, running a batch of tests, trying to then come up with should we use that package. The tests are all the things that you'd think of looking at. Do I know the author? Is it well maintained? Unit tests, all that sort of stuff. That's Litmus, right? Apps are just harder than packages, right? That's basically what this talk is coming down to. So validating a package turns out to be a bit annoying and a bit tricky and a bit painful, right? Because packages come in all shapes and sizes. Apps are just harder. And the way of thinking about why apps are just harder is imagine that your app is just a package, right? Doesn't have to be, but let's just go for that to start with. So imagine that your app is just a package. So we can now validate that app as a package, but it's just more complicated, right? So this general idea, when I think about validating Shiny apps versus packages is, well, if your app is a package, then we can run through all that stuff in Litmus, right? We can get all those scores and do all that validation, right? But then we actually also have to do a whole bunch of additional Shiny assessments as well, right? And the reason for that is users, right? Packages are a bit more constrained, a bit more fixed, less leeway. Whereas apps, people go pointy-clicky mad, right? Users do whatever they want. So actually then trying to validate an app is just fundamentally harder. It's exactly the same as a package plus some other stuff, right? And so essentially the general idea is what we're going to think of is if we think of an app as a package, it doesn't have to be, but it's a good baseline. We can do all the stuff that we normally do, look at who uses it, dependencies, longevity, unit tests. And then also think about, well, it's actually Shiny, so we shouldn't ignore that part. What additional parts are we going to do? So for the rest of this talk, I'm just going to think about this square here, right? So I'm already thinking about unit tests, I'm already thinking about dependencies, I'm already thinking about popularity and all that sort of stuff. But now what else do we have to do because it's Shiny App? Okay. So users are generally annoying. Not as annoying as IT, that just doesn't work. Yes! We have sound and everything.
Hello, IT? Have you tried turning it off and on again? Hello, IT? Have you tried turning it off and on again?
Hello, IT. Yeah, have you tried turning it off and on again?
Hello, IT?
Something's wrong with my computer.
Have you tried turning it off and on again?
No, I'll do.
And that sort of sums up users. There's another one of, after that, then they say, is it plugged in? And then the users go, oh, no, it's not plugged in, and then they go away and fix it. And users just make things a bit more tricky, right? You sort of, you design your app, you've got your menu, you know exactly the workflow that they're meant to do, and they just don't do what they're meant to do, right? And we could have a debate over lunch of, is that our fault or is that their fault? It depends on which side of the room we're on. So what are the unique challenges? Okay. So users may trigger untested or invalid outputs. Right? One of the fun things I like doing is when I come to an app, I just like putting in random rubbish to see what happens. It's just a bit of fun. What happens if you put a very big number in, or a very small number in, or whatever, right? That's fine. Except if it's sort of in a validated context. So if it's something to do with finance and someone puts in a negative number, does it just strike off the negative part and does something? Is it catching all those sort of odd extremes that, users just shouldn't do that, but they do, right? And so it's controlling user-controlled output. That's tricky, right? And so, they trigger untested, invalid options. They also just do things that you'd never imagine in a million years. Just why would they do that? Just why? But they could. So here we sort of need to do logging key actions. When we think about validating downloadable content, if they're downloading graphs and that sort of stuff, how do you make sure what they're getting is correct? Restricting custom inputs, putting as much guardrails in to valid ranges as possible. Right? And again, where you are in that sort of, I suppose, validation journey depends on how much you want to do with this. If it's your demo app that you've built on a Sunday afternoon because it's a bit wet outside, then you're probably not interested in logging. If it's something to do with banking, medical research, health, then it's a lot more important, right? It's where you are on that spectrum. No native audit trail, right? So Shiny doesn't track user actions or input history. So again, logging here is really important. There's a whole bunch of logging packages out there. There's a nice blog post. So if you search for blogs and logging, there's a whole blog post discussing logging packages out there. It's quite nice. But again, so it's all about making sure you know what's happened. So then when if a user says, well, I've got this number from your app, and I've got this graph, and I've got this report, and you go, oh, it doesn't look quite right. How do you then trace back what's going on, right? And of course, you're wanting to log the app version and package snapshots. And of course, we all have an app version when we're building this stuff, don't we? Because that's clearly what we'll do. Behavior can differ across in deployment environments. This is sort of gets a bit more tricky, okay? So you've got it validated, or you've got it running on your laptop. But for it to be of much use, it has to be somewhere else, it has to be on a server. So how do you make sure that what works in your laptop is working on the server? Okay, so it's that component. And, so you might have come across RMF. That's the way of sort of specifying which package you're using, and then you can deploy it in your server and matching that. You've got Docker. So Docker is essentially just a big container where you can specify exactly what the operating system is, what dependency you need, how it's installed. It's much more, I suppose, detailed of how to deploy it. And again, you're not just sort of working on the dev builds, you're thinking about the thing that's actually running in action. So we started over the last few months deploying POSIT for invalidated environments, right? So what that means is working with some pharmaceutical companies, deploying POSIT infrastructure. We've been doing this for years, except the twist to this is we now need to be able to demonstrate how did we install it? Who installed it? How are we sure that it's working? Have we actually changed anything? Very well documented. So it's not good enough just to say, yes, we're doing it properly. We actually have to be able to say, yes, we're doing it properly. And look, Here's the records to say that we've done it properly. These are the records to say that we've deployed it. So it's sort of here. It's not just enough to say, well, it works in my laptop. But once it's deployed and it's using Docker, how do you know that it's working as you expect? You know, how do you know it's connecting to the right database? What are the steps you're doing? Right, it's a bit more bureaucracy. Bureaucracy also got a bad name, but sometimes it's important. Real-time inputs create complex dynamic states. You're connecting to a database, and the database is changing, and that's painful because now it's changing and things are changing. So you've got lots of tests, you know, so again, I suppose the extreme way of thinking about this, if you've got an app that's completely mission critical, the point that you're getting to is you're wanting to constrain that as much as possible. You know, you've got a balance. You know, if you've got an app that does lots of things, it's much harder to make sure and be confident and demonstrate that all combinations of all inputs and outputs can do exactly what they want. So there is a tension, okay? So define expected input combinations. So if you've got a menu, or a sidebar with 100 different options, that's a lot of work to make sure they're all doing the things you need. So again, there's that idea of risk. Where are you on that risk? You know, is it, I'm okay with that risk? I can't completely guarantee that everything's working, but it's okay. Or is it, actually, this is dealing with patient data, and it's really important, and life and death decisions are going to be made in this, in which case it's more constrained. Reactive changes. Isn't reactivity wonderful? So here it's about thinking about how do you actually write tests for this stuff, right? You know, so you click a button and then you've got a whole sort of stream of reactivity going through your app. Lots of logging to trace these dependencies. I quite like the idea that Charlie was talking about, you know, open telemetry, just sort of make sure, another view. Thinking about breaking logic into testable functions, right? So testing Shiny apps is hard. So if you can take as much logic, much business logic outside your app as humanly possible, testing in an R package is so much easier, right? You know, testing a function that manipulates a data frame is easy. Testing a function that manipulates a data frame inside your Shiny app is hard because you've got sort of inputs and outputs. It's about thinking about taking that stuff away. Traditional unit testing doesn't cover, so test logic outside the Shiny context. If you can get a package, for example, that contains all that logic, so nothing to do with Shiny, that's so much easier to test, right? You know, if you've got a separate package that's got all your business logic, that does all the sort of manipulation, building reports, that's much easier to test than having it all inside your Shiny app, okay? So doing this sort of validation, again, thinking about that line of where you are, right? You might not be working in a regulated environment. You might not need IQ, OQ reports, so installation reports, operation reports, but you're wanting to build something robust. So it's where you are in that line. And it comes down to basically software engineering practices. You know, so when we're talking about validating Shiny apps and working in the pharmaceutical industry, it's about thinking about these sort of good software practices and what we're going to implement. Right? So if you don't have it in Git, I wouldn't worry about doing Shiny test 2 today. Right? You know, so if it's not version controlled, make it version controlled. You know, that's step 1. Right? If you don't have, if you're not doing any sort of code review, do that before you do Shiny test 2. So it's, you know, think about a continuum of where are you on that line. But if you're doing something in validation, well, you need to cover all these things. But if you're not doing something validated, where are you going along this line? And I've tried to put it in sort of order. That's linting, in case you're wondering. Documentation. So functional requirements specs. Do we actually have a document that tells people what the app's meant to do? There's a question. I suspect the answer to that is no, a lot of the time. You know, so actually detailing of, if I click this button, this happens. If I type in this, then this happens. You know, that functional requirement specification. User guides, readmes, all that sort of stuff. Audit trail, who changed what and why. Right. Git takes care of a lot of that, but some of these things are quite straightforward to do. Reproducibility evidence, the RM block, the Docker file, you know, what do you want to do? That might be overkill for what you're doing, or it might be perfectly fine. And hopefully this has sort of come across, but what I was trying to get at this talk is thinking about your application or your package or anything you actually write in anger and going, how important is it? right? Because what it comes down to is doing all this stuff takes time. Time essentially costs money, and it's do we have that time and money to do that? And it might be better doing something else. So if they're low risk, they're messing about, they're just sandboxed, then you can sort of move that line a bit. You might want a little bit of testing, but not so much. You might actually just start doing a lot of this stuff automatically. So I'm guessing, if I did this talk a few years ago, Git would have been something about what's Git. I imagine most people are using Git regularly now. It's not so much surprising. And it's no longer think of, oh, this is advanced software, it's just, this is what we do. Likewise, if you're not using CI/CD, so continuous integration, it's not that hard. It's quite an easy thing to get going. Whereas high-risk apps, so regulatory outputs, well, you need to make sure you tick all these boxes, and you need to make sure that they're documented, and you need to make sure that they're followed and everything else. Okay? So it's all about defining the intended use. That's when it comes down to. So when we think about regulatory apps, we're thinking about what's this thing going to be used for? How is it going to be used? Who's it going to be used? Are you sure that this thing works? That's sort of the questions we're trying to answer. And that's what I've tried to get at. All the sort of stuff that you do, hopefully normally, we just need to make sure we're done consistently. So 2 slides to close, and that's me. Build validation good design from day one, right? So if you've got an app, stick it in Git, fine. Start off with those sort of simple practices. Start off with just sort of doing the right thing. So much harder to move back. Likewise, rather than putting all your code right into your app, try and think about that separation out from the start. You can do that from the start, great. Life is just a happier place. Automate wherever possible. If I'm honest, I quite like automation. I'm a bit bored with documentation. I'm not a very good documenting thing, but I quite like automating because that's more fun. But you should do both, and I try to do both. And then sort of choose tools that support transparency. What's that mean? Well, think about Git. Think about, can you see who changed what? Can you think about the order things changed? All that sort of stuff. So Shiny apps, just like any other app, powerful, but bad things can happen. Validation is about trust. It's about good engineering. It's about doing what we're meant to do, but actually ensuring that we've got the documentation and processes to ensure that it actually happens, not just trust me, I'm an R developer. So thank you very much, and happy to take questions.